Okay, we're looking at number 13 now. Terry drove 366 miles in 6 hours at a constant speed. How long would it take him to drive 427 miles at the same speed? So how long? Once again, ratios. 366 to 6 hours to 6 hours, miles, hours. And that's going to be proportionate to 427 miles. Whoops, I was going to write miles. 427 miles. And we don't know how long, how many hours. X. We don't know. Once again, cross products is this. If these are two ratios are proportionate, we're looking at proportions. We've been looking at images that are proportional, distances, weights, etc. All the same. Cross products are our friend. This times this. This times this. 366 times x. That's proportionate to 6 times 427. Okay, guys, I'm going to cheat here again. Sorry. 6 times 427, just to save time here, 2,562. So 366x equals 2,562. 2,562. This is a comma. So how do I isolate the x? I divide by 366 each side. That cancels out. 366 divided by 366 is x. Hence, it's isolating the x. So I divide this side by 366. Rather than have you watch me, we know how to do it. It takes a while. So 2,562 divided by 366 is 7. So it's going to be 7 hours. And let's see does that make sense? So 366 miles in 6 hours and 427 miles, 7 hours. It's a little bit further. So 61 hours is ridiculous. And it's further, so it's not going to be less time. It's going to take longer to drive further. That's ridiculous. And then this is going to take, that's only a half hour longer. So this is actually longer, but it's only a half hour longer. It's quite a bit further here. So it's not going to take just a half hour to go this, additional miles here. It's going to eliminate that one. And it's certainly not going to be less. 3 hours is less. So it does make sense if you kind of look through 366 to 6 hours, 427 miles, 7 hours. So let's move on. And look at number 18. So we're looking for a missing size. If these two triangles are similar, they have the same proportions, what would this size be? So let's do our corresponding side. This corresponds to this. This corresponds to that. This corresponds to this. So you write it out, 9 to 3. Now for these rectangles, for these triangles, we only need two measures. Since we already know they're similar, we just need to pick one ratio to compare. And this to this. 3 to x. Well, these are the same anyway. This is supposed to be a 3. So I just choose any of the proportions since they already told me it's similar. These are similar. So all the proportions, they're giving it away. They're going to be proportional. 9 to 3. So 9 to 3 is going to equal to 3 to 6. If these were different sizes, they'd be proportional. So 9 to 3. This confused a lot of people. Let's just pick one because we already know it's similar. Confused a lot of people. Is proportionate to 3 to x. Again, cross products here. 9x is equal to 3 times 3 is equal to 9. So how do I isolate the x? 9 times x equals 9. If I divide each side by 9, I I get to isolate the x. 9 divided by 9 is 1, so I have 1x. If I divide this side of the equal sign by 9, I also have to do the same to the other. 9 divided by 9 is 1. So my answer is going to be 1. X equals 1. And now I feel silly for even solving it because this triangle's smaller than this one. So the side's not going to get larger. This is going to be 27. So I think they're encouraging us to guess and not work these out. But that's just me. Anyway, it's good to solve it out anyway, just to check it and make sure we know this is 1 and the book didn't make a mistake. Okay, but it's good to always look at the choices and ask yourself, does my answer make sense? And it does, because the sides are going to get smaller.